Hey everyone, thanks for sticking around to the afternoon in the IoT track. Fantastic. I'm really excited to welcome Karen, Sun from Dwelo. Really awesome use case, really great customer. She's going to talk about a couple of different Twilio products. Just a really, really fun use case for the IoT. Thanks, Karen.
Okay, thank you, Vanessa. Hi, everyone. Oh, yes, my microphone works. All right, so I have a really exciting talk about automation in your home. It could happen to you, too, in your home. And this is actually already misleading because I'm going to talk about apartment automation, not home automation. But it seems like home automation is the phrase that most people are familiar with, so we're just running with that. I work at Dwelo. Dwelo is a company in apartment automation, like I just mentioned earlier. So we provide a suite of services that connects devices in your apartment. I'm going to get into some of the particulars of that later, but not only do we provide a way for you to remotely access your lights, locks, and thermostats, we offer integrations with voice control like Alexa and Google. We also do integrations with things that are more specific to apartments and not individual home units. So, for example, you have to pay rent for your apartment. You have to get into the gate that surrounds your compound. So these are all the other types of integrations we handle, and we centralize the experience for you. And we are Dwelo. It's Dwelo with one L. Dwelo with two L's is a Canadian rent payment company. It's also not to be confused with Twilio, which is like 3 edit distance away, or Wellio, which is a company that just got bought by Heinz. Dwelo with one L. All right. So today I'm going to dig into a little bit of what the technical landscape actually looks like when implementing these solutions. And we're going to run into some problems immediately. And I've already given you 2 of the punchlines, but we'll talk about how we actually solve them. All right, so we work with apartments, which means we don't just cater to people living in apartments. We also have to make sure we provide this seamless, integrated experience for all of the players in the space of apartments, which means you have people who live there, the residents. You also have people who manage the properties. So these can look very different depending on what type of apartment you live in. I'm sure you've been locked out before if you live in an apartment, and then you have to call someone up. They have to let you in. That's the property manager. And also, there are the actual owners. So there are people that actually construct these, the construction groups that build these apartments. There are all these ownership structures in real estate. So we are selling directly to them. And we need to make sure that this experience from beginning to end, from installing the devices, making sure everything works when all the units are empty, to when people move in, and making sure that both sides of that equation are seamless and frictionless, like that property managers have an easy time moving people in and out, troubleshooting issues, contacting their maintenance staff and giving them the right type of access controls, as well as people living in the units feeling safe and feeling good about the type of access people have to their units. All of that has to be centralized and seamless. So that is kind of, in a nutshell, our ecosystem. And I touched upon some of this earlier. So more specifically, there are a lot of spot solutions out there right now for different kinds of devices you might need to interface with. Right now, we do locks, lights, and thermostats, but I'm sure people in the audience here have other things they probably control through a mobile app. I think the one I heard most recently was someone had a smoker, which like alerts you every hour how ready your meat is in the smoker. So stuff like that. Everything is becoming connected. And for example, common areas are not just outside to the apartment, but inside. So maybe you have like a shared business area or shared conference rooms in your high-rise that you need to reserve space for. These are all the different types of considerations that you get into with an apartment. Just to dig a little bit more into what managers face constantly. So managers don't just necessarily manage one building. Sometimes like many buildings share one manager. So if people are locked out, let's say, they spend all day running around, literally just opening doors with huge sets of keys. And that is just a huge inefficiency in the process right now. So that's one type of thing we can solve with remote access. The other thing is a lot of time, this is just an inventory problem. So when units sit vacant and seasons change, you need to know exactly what state you want to keep your unit in for the optimal cost savings. And previously, this is just something you kind of guess. You're like, I think it's summer, I'm going to try to get the thermostats to keep the place at around like 75 or 80. But that's not very scientific. And in fact, we can give you a way to automate that process so you can always make sure equilibrium is giving you the lowest cost option. Okay. So yeah, how many of you out here have smart devices in your home? Wow, San Francisco. And how many of you control stuff through Alexa or Google Home? All right. And then how many of you have more than one app that you have to interface with? Wow, okay, cool. So that's the reason why I never outfitted my home before Dwelo with anything, because you get this fragmentation whenever you start to apply all these smart solutions. So maybe you have a doorbell and it has like a panel display on the wall, but then you need to go and control your locks through Alexa. And then maybe you have a separate app for that smoker I mentioned earlier. So it's a very fragmented space right now. And it's fragmented for good reason, especially when you bring hardware into the equation. There are a lot of custom solutions out there. They all communicate with different protocols, / people want to kind of build this moat around themselves, so they make everything proprietary. And that makes it really hard to then centralize all of these things. There's no kind of like app store for your home that applies to smart devices. So this is kind of what it looks like right now. Here are a couple examples. Basically, you have some devices that can speak to the internet, some that don't even. Maybe, like I think a lot of doorbell solutions are a good example of that. There's a video feed, it links to the panel in your home, and that's it. Now, Dwelo begins to solve this problem. So we manufacture a hub that sits in each unit, which is basically just a Raspberry Pi. And that implements the Z-Wave protocol to talk to devices that also talk Z-Wave. So there are two common low bandwidth protocols in smart devices. One is Zigbee, one Z-Wave. And we basically offer anything in that catalog. So our hub then talks to our cloud. And once we can get devices controlled through the cloud, then we open up a whole new world of possibilities. So in this case, I'm just demonstrating how now we can actually integrate with Google Home and Alexa skills. And that is something which we do offer today. Okay. So in case you couldn't tell, everything here needs internet connection. That's super important. So real quick, it's not only important that you have internet connection for controlling things. That's the end user experience, just needs to work. There are a couple other basic things that need to be in place for a good manager experience as well. So, people move in and out of apartments. It's not just one person's home who decided to buy the entire suite. They need to be able to diagnose everything going on. And not only do you need to push new credentials, not just logs have credentials, so many other things are requiring those these days. If, let's say your thermostat's going haywire, you need to know why is that happening, or at least get alerted so you know you can start responding. The other thing is that this is people's homes, and you're starting to skirt with physical security and safety. I think this is becoming a wider and wider discussion, especially as more homes become smart-enabled. Who gets access to a home? What happens when your credentials get loose in the wild? Can they be hacked? Things like this. So it's really bad if we can't reach the devices, both on the Dwelo side, on the property management side, and for the residents. And just a couple more things that might happen. I think one of the things I want to call out is we essentially just have servers running in all these people's homes, and we'd like them to have the latest and greatest. The other thing that happens pretty commonly, especially if you've worked in IoT before, is that your devices can just go offline for any reason, and maybe you don't know why. But then you just can't administer them. You can't send software updates. You're like, oh crap, I have a really, really sensitive stepwise deploy I need to make, and you just think I'm just gonna have to let go of 10% of my fleet or something if things are not internet connected. And finally, a little bit more about what internet connection logistically looks like in the apartment space. So bulk internet is where apartment buildings provide the internet. And basically, you move in, you don't have to call Comcast. You don't have to call Comcast and set anything up. It's just there for you. But that's common in some locales and not other ones. So typically, what we're facing is we go into an entire building, and we need to be able to register a hub, provision IDs, tell our server exactly what devices to expect in an apartment. So when someone moves in, they just have a turnkey experience. And we can't do that if they don't have internet connection. And it turns out even if you think you have internet connection, you might not have internet connection. Great. So it turns out there's a solution for that. It deals with the company we're currently at a conference for. And Twilio Programmable Wireless offers you an end-to-end solution for internet connectivity. So you can basically get SIM cards, and that provides you internet connectivity over cellular data. And it's actually even more feature-rich than just giving you that spot solution. So I'll go into that a little bit. So I mentioned this hub earlier, which is just basically a Raspberry Pi, and this is a picture of the cover off. So here you can see, I don't know if you can see my mouse. Yeah, you can see we have a Telit chip, which manages the cellular connectivity, and we have a Twilio SIM card right there. And there was a while where we actually were not integrating this into our boards and just running into a bunch of connectivity issues. And then we decided, there's so many good reasons to have this, not only for the vacant move-in experience when you might not have internet, but just as a backup. Like I mentioned earlier, stable internet is actually something you should never count on. You can only really begin to count on it when you're deploying to, let's say, cloud servers or something, and you have an entire DevOps team there making sure you have redundancy and everything is staying online. But especially in someone's home where you just have one copy of something, it is likely to go offline definitely at some point over the course of a year. So this gives us connectivity, and it turns out we get other things for free using Programmable Wireless. So we can also monitor data usage and cost on a per SIM basis. And this is also really helpful for us because we can cross-reference this with all of the metadata we have in our databases about where our installs are. Maybe it's different regions of the country. Maybe it's seasonal, things like that, and we can pattern match on it. Okay. So we solved the internet connectivity problem somewhat. And it just turns out there's a lot of other things you need to basically build for, account for in an IoT stack. And I'm going to start talking a little bit about synchronization. So here is the original diagram with a little more about what the users actually interface with. So users can control their devices not just through one entry point, which is this centralized experience through mobile apps or through a web platform, but also they can just go and hit their light switch. It would be absolutely awful if we said you have to use your phone, it has to be charged, you can't actually go and turn the light switch. So take that and multiply it with the fact that there can be multiple users sending these commands at the same times to the same devices, and all of the possible ways you might fail in this whole loop, like maybe your hub goes offline or glitches or something like that. Maybe your app itself loses connectivity. So all of these things means we tend to end up in a lot of like partial states along the way. And we really need to figure out at any given point in time, what is the current state of all our devices? Like, is our door locked? Which is just a huge security question. And then what state do we want it to be in? What are the in-flight commands? Okay. So what we're really looking for is a single source of truth. And there's some requirements for this. We would like to figure out how to cut out the need to depend on any part of our stack in order to communicate with this state. So we'd like all of our clients, like our mobile apps, our web front end, our hub, anything really that might exist in our stack, we want them to be able to all subscribe and write to this state. Also, we are modeling all sorts of different things. I'm going to be digging into one use case, but basically, even if you're thinking about modeling state for devices, a switch can be on and off, but that is the only thing that's binary out there. Thermostats, depending on how old they are, how new they are, have all these different settings. Some of them have a set point, some of them have dual set points, some of them have different types of sensor readings, some of them read humidity, some of them don't. So basically, you need this ability to be really flexible and model the union of all the different things you might want to know or command your device to do. Okay. So Twilio Sync. How many of you out here use Twilio Sync and know what it is? Okay. Oh, well, half of the hands are people from Dwelo, so I'm going to assume more people have smart devices than know what Twilio Sync is. So on the website, Twilio Sync is a real-time state synchronization service in the cloud. I feel like that almost uses itself to define itself. So I'll just go into it a little bit here. So it's serverless, meaning Twilio manages and runs in the cloud, so you don't have to manage or any deploys or anything like that. And it offers you document-based state. And you can represent state, NoSQL, as JSON. And you can communicate with all these documents representing all sorts of state using a variety of protocols. So I'm going to dig into all of this. And when it comes to managing state, or just basically managing a series of documents, there are a lot of possible solutions for that. I feel like a lot of what you could come up with off the top of your head is probably a little bit hacky and involves you having to build up an entire service just devoted to that, and then managing a bunch of servers and needing them to be highly available and redundant and all of that. But Sync is uniquely suited for this. So the first thing I mentioned was that we need flexibility. So not only do you have these document-based state, you can do delta updates to them, meaning like any partial part of the document, and you get some different types of structures out of the box. So you can represent things as maps, or you can even manage state over arrays. And just to kind of show you what that looks like in our system, this is where I had to make my own diagram. So it's just like a box. And basically, for every single device in our system, we can key on that device ID, and we use maps. And then we keep track of the desired state and actual state. We have another kind of pipeline for commands in flight, which I'm not going into. But for example, this is what it might look like for a thermostat. So you need to know if your thermostat's on in the first place. But if it's on, what kind of mode is it in? Are you trying to cool or heat? Or is it on fan? And then where do you want the actual temperature to go? So ideally, if things are at rest, the desired state and the actual state can be the same. Should be the same. So this is very powerful because at any given point in time, you can kind of sweep through all the maps you have, and you could schedule something and be like, is everything in sync within sync? And then maybe run some sort of script to go through and issue more commands or diagnose and see what's wrong. So this is at rest. And then we can issue map updates. And in this case, we can issue a map update with a command key and give it a delta. So what do we want to update and change? And in this case, we're changing the mode and changing some of the set points. So super simple. This is all represented as JSON in a post payload if we're using like the REST API. So we can model everything now, but we need to communicate with Sync. And Sync, out of the box, gives you a lot of different options. It was clearly designed for IoT in mind. And over here, this just kind of gives you a map of all the different protocols we have in our system. So earlier I mentioned that we have devices that have to communicate with our hub using Z-Wave, and that's over here on the left. So that's really the edge communication right there. That doesn't involve the internet in any way. And then the industry standard for IoT communication is Mqtt, which is also a low power, low bandwidth protocol, and that's something that just comes out of the box with Sync. So we use that on our gateway to communicate with Sync maps for all these different devices. On the client side, in the mobile apps, there are SDKs out of the box also for iOS and Android. We use the WebSocket option for JavaScript, and then our server uses the REST endpoint, and there's a webhook also over REST. So I alluded to some of this earlier in that there's all of a sudden this single source of truth that's highly available. We don't have to worry about it. We can just keep feeding it as many maps as we want, as many updates as we want. We get atomic push and pull. And not only that, there's actually really easy documentation. You can just get up and running with a couple lines. So this is the reason why we want to Sync. So now we have state synchronized. We know what the current state of all of our devices are, and we know at any given point in time where we want them to be. What we still need to do is basically be able to inspect all of the updates that have ever come through for all sorts of reasons. I think an obvious one is analytics. It would be really good to know, like, which users are super active during what times of day, even like who is issuing commands. There's security reasons and motivations baked into here. So we built a serverless solution to basically warehousing everything that comes through Sync in AWS. So there are a lot of like boxes here, but I'll describe the gist of it. So this is something we call reflector internally, because we're reflecting all the updates and changes that are coming through that interact with Sync. So we basically run a Lambda that exposes a REST endpoint, which is the webhook that is called in our Sync fleet. And every single time a CRUD operation happens in Sync, it writes the payload of what that operation contained into our Lambda, and then we shuffle it over to Firehose. We make a copy in S3 as a blob, and then we also copy it over to Redshift. And that allows us to then do like the bulk of our analytics, even over long periods of time, over large numbers of keys. And then if we want, the power of getting it into Firehose is that then you could get it into any sort of like analytics optimized backend that you would like to use. So we've actually started to branch out and use Sync for quite a few things because we don't have to think about it as just state. It's kind of this repository for storing information about anything that was executed at any given point in time. So we centralize device state there, but we also use it to track certain in-flight values for some of our cloud integrations. And now we are using it to complement our Celery task observability, because you just like don't get enough out of the box with the in Python. Yay, and this is how it looks today. I guess instead of users in the bottom right corner, there's a sync thing now. But basically, we have a hub that is now really happy to be connected to the internet with a SIM card. And everything talks to sync. So we went through this like couple-month process where we were changing like what everything spoke to or wrote to or expected to talk to sync. But it's really powerful because now if we, let's say, want to develop a new set of dashboards or administrative tooling, we just go to that one place. Thank you very much. And believe it or not, we are hiring. So I'm just going to leave this up here. And I think I have a couple minutes if anybody has questions. Thank you.
If anyone has a question, I can run a mic around. If you want to stay up there.
Sure, yeah.
Okay. Does anyone have a question? No?
That's
Okay.
totally fine.
Cool.
Oh, there's one.
Oh, there's one? Hey.
I'm not sure if you actively manage these devices once you put them out there. Like, how do you deal with like SIM cards that maybe if you have like failures or anything like that?
That's such a painful question. We do.
Sorry.
We do the whole end-to-end process from install to like white glove install and response and support to all the software upgrades that need to be made. So there are a couple things there. The first thing we always try to do is just like reboot. Like if something looks wrong, try to convince the person living there to like turn something on and off. Before that, just like see if it's plugged in. There's like a whole run book here. In the worst case scenario, we do a truck roll. So we actually do go and fly someone out and like schedule time and go and swap in a completely new hub. We do have an entire team that's been working on these type of questions. Like what are all the reasons why, like what are all the different failure states you might get into? So we get like corrupted disks. We just like sometimes are unable to connect to cellular data even if we switch over. So there's just a whole host of problems. I don't have a better answer than that.
That's good. Thank you.
Yeah.
Any more questions? Cool. Thanks so much, Karen.
Thank you.
That was awesome.